Okay, this is a lesson for chapter 16.1 or lesson 16.1, and we're just talking about exponents here. So this should be hopefully a review for you guys. A power is a product of repeated factors. The base, that's the big number, not the exponent, of a power is the common factor. The exponent, the little number, of a power indicates the number of times the base is used as a factor. So here, and just a side note, notice when you put a fraction raised to an exponent, you put that fraction in parentheses, or that exponent would only apply to the numerator. So we do put it in parentheses. So this is 1/2 to the 5th power, which means 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So 1/2 is used 5 times as the factor. Then we will write each of these as write expressions using exponents. Here, this is -7, so they put it in parentheses. Remember, study tip, use parentheses to write powers with negative bases. If the base is supposed to be negative, you got to put it in parentheses. So this would be -7 times -7 times -7 is -7 to the 3rd power. Again, the -7 has to be in parentheses. Here we have pi times pi, which is pi squared, and we have r times r times r, which is r cubed. Pi squared, r cubed. You could put a dot in between those two, but you don't have to. You can put them right next to each other. You're going to start seeing that kind of notation a lot, actually. So pi squared, r cubed, all multiplied together there. So now we're supposed to do a couple of these on our own. I know that was pretty quick and easy, hopefully. So let's look at this first one on your own, number 1. On your own, number 1, I've got a 1/4, and I've got it 1, 2, 3, 4, 5 times multiplied together. So I have 1/4 to the 5th power. Of course, I can't leave it like that. It does need to be in parentheses. So 1/4 to the 5th power is the answer to number 1. And for number 2 over here, I've got 0.3 multiplied together here, used as a factor 4 times. So 0.3, that's interesting. I technically could just do this, but that's a little confusing. Boy, if you put that in parentheses, it's not confusing at all. So when we have a decimal number, we normally put that in parentheses too, and then that is times x to the 2nd power, because I have 2 of those, x squared. Notice I didn't put a dot in between those. I just left them right next to each other, implying multiplication. Well, the next part is evaluating expressions, so figuring out what these things mean. This, of course, is -2 to the 4th power. It's in parentheses, so the -2 is the factor. -2 times -2 times -2 times -2. I have an even number of negatives, so my answer is positive. 2 times 2 is 4, times 2 is 8, times 2 is 16, positive 16. This, very similar, but no parentheses. So this just means a negative out in front of 2 times 2 times 2 times 2. Well, 2 times 2 times 2 times 2 is 16, and now I put that negative on. My answer here would be -16. So you can see 2 different answers. In fact, opposite answers, as 16 and -16 are opposites. A little math humor there, but not really, but kind of. Okay, using order of operations, which is kind of what our fair game review was yesterday, but here we got this going on. First thing we have to do here is this exponent. So this is 3 plus 2 times 3 to the 4th power, which is 3 plus 2 times 81, because 3 times 3 times 3 times 3 is 81. Well, now I do this multiplication, so I have 3 plus 162, and finally I get 165. The second example they gave us, 3 to the 3rd power minus 8 to the 2nd power divided by 2. First we do these powers, so I get 27 minus 64 divided by 2. Now I do my division. 27 minus 32. 27 minus 32 is -5. And then they give us a couple to do on our own. So number 3, evaluate the expression -5, no parentheses, to the 4th power, which of course means -5 times 5 times 5 times 5. And 5 times 5 is 25, times 5 is 125, times 5 again is 625. So my answer here is -625. For number 4, negative 1/6 to the third power. So it's negative 1/6 times negative 1/6 times negative 1/6. Well, negative times a negative is going to give me a negative, of course, because I have an odd number of negatives. And 1 times 1 times 1 is 1. And 6 times 6 times 6 is 216. So my answer for that one is negative 1 216th. Negative 1 216th. Okay. Number 5, interesting. We haven't used absolute value signs in a while. It is just a grouping symbol there, but we have to take the absolute value when we're done. Negative 3 to the third power divided by 27. Okay. Well, it wouldn't really matter, but we're going to do it right anyway. So 3 to the third power is 3 times 3 is 9 times 3 is 27. And then I apply the negative. So I have negative 27 divided by 27. Well, negative divided by a negative is a negative. Negative divided by a positive is a negative. And 27 divided by 27 is 1. So negative 1. But we do have it in absolute value signs. The absolute value of negative 1 is, of course, 1. And finally, number 6 here. 9 minus 2 to the 5th power times 0.5. Well, the first thing I take care of is 2 to the 5th power. 2 times 2 times 2 times 2 times 2 equals 32. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yes. So now I have 9 minus 32 times 0.5. Well, I don't do this subtraction yet. I have to do this multiplication. 32 times 0.5 is 16. So now I have 9 minus 16, which is, of course, negative 7. So the answer for number 6 is negative 7. Well, that was a pretty quick and hopefully easy lesson. It's just mostly a review of exponents. Now you can go and do the journal page, which is journal page 370 that goes along with that, and then answer the questions. Later.